It's one of the most perplexing questions in cosmology. Does our universe have an edge? If so, then what lies at the very edge of the universe? If you keep traveling through space in an imaginary faster-than-light spaceship, would you ever arrive at some boundary, unable to go any further? And if the universe does have an edge, what lies beyond it? It's all very hard to imagine. Then again, an infinite universe is just as difficult to wrap your head around. After all, there must be something that space is expanding into, right? Let's start with a related but easier to grasp concept. Our universe has an apparent edge, called the cosmological horizon. The light emitted right after the Big Bang has been traveling for 13.8 billion years through space. This means we can only see the universe up to a current distance corresponding to a light travel time of 13.8 billion years. Thanks to the expansion of space, this so-called co-moving distance is approximately 45 billion light-years, and anything beyond this limit is unobservable to us because not enough time has elapsed since the birth of the universe for light from these remote regions to reach our telescopes. But just like the familiar horizon seen by sailors on the ocean, this cosmological horizon is not some real, physical boundary. And as the ocean stretches beyond the sailor's horizon, so too does space stretch beyond our observable universe. There's no reason why there can't be galaxies at these extremely large distances. They're just invisible to us, no matter how powerful our telescopes are. But knowing the universe goes on beyond 45 billion light-years still doesn't tell us whether it's finite or infinite. One thing's for sure, the universe does not have an edge. There's no physical boundary, no wall, no border, no fence around the edges of the cosmos. This doesn't necessarily mean that the universe is infinitely large, though. In principle, we could live in a finite universe, provided that three-dimensional empty space is geometrically curved in a particular way, a distinct possibility according to Albert Einstein's theory of general relativity. If the universe has what's known as positive curvature, it would be like the curved surface of a beach ball, but rather than a 2D surface, it's 3D space. Today, we see the universe as it exists 13.8 billion years after the hot Big Bang. Most of the galaxies we see are clumped together in galactic groups, like the Local Group, and rich clusters, like the Virgo cluster, separated by enormous regions of mostly empty space known as cosmic voids. The galaxies within these groups are a mix of spirals and ellipticals, where a typical Milky Way-like galaxy forms an average of about one new Sun-like star per year. In addition, the normal matter in the universe is mostly made of hydrogen and helium, but about 1 to 2% of the normal matter is made of heavier elements from the periodic table, enabling the formation of rocky planets like Earth and complex, even organic, chemistry. While there's lots of variety, some galaxies are actively forming stars, some have active black holes, some haven't formed any new stars for billions of years, etc. The galaxies we see are large, evolved, and clumped together on average. As far as we can tell, there is no edge to the universe. Space spreads out infinitely in all directions. Furthermore, galaxies fill all of the space throughout the entire infinite universe. To answer the question of what's at the edge of the universe, we first need to define exactly what we mean by universe. If you take it to mean literally all the things that could possibly exist in all of space and time, then there can't be anything beyond the edge of the universe. Even if you imagine the universe to have some finite size, and you imagine something outside that volume, then whatever is outside also has to be included in the universe. But the universe doesn't need that edge perspective in order to exist. The universe simply is what it is. It is entirely mathematically self-consistent to define a three-dimensional universe without requiring an edge or outside to that universe. When you imagine the universe as a ball floating in the middle of nothing, you're playing a mental trick on yourself that the mathematics does not require. Granted, it sounds impossible for there to be a finite universe that has nothing outside it. And not even nothing in the sense of an empty void, completely and totally mathematically undefined. In fact, Asking what's outside or at the edge of the universe is like asking what sound does the color purple make. It's kind of a nonsense question, because you're trying to combine two unrelated concepts. Note that humans can only see part of the entire universe. We call this part the observable universe. Since light travels at a finite speed, it takes a certain amount of time for light to travel a specific distance. Many points in the universe are simply so far away that light from these points has not had enough time yet since the beginning of the universe to reach Earth. And since light travels at the very fastest speed possible, this means that no type of information or signal has had time to reach the Earth from these faraway points. Such locations are currently fundamentally outside our sphere of observation, simply put, outside of our observable universe. Every location in the universe has its own sphere of observation beyond which it cannot see. Since our observable universe is not infinite, it has an edge. This is not to say that there is a wall of energy or a giant chasm at the edge of our observable universe. The edge simply marks the dividing line between locations that Earthlings can currently see and locations that we currently cannot. And although our observable universe has an edge, the universe as a whole is infinite and has no edge. As time marches on, more and more points in space have had time for their light to reach us. Therefore, our observable universe is constantly increasing in size. You may think, therefore, that after an eternity of time, the entire universe will be observable to humans. There is, however, a complication that prevents this. The universe itself is still expanding. Although the current expansion of the universe is not as rapid as during the Big Bang, it is just as real and important. As a result of the expansion of the universe, all galaxy groups are getting continually farther away from each other. Many galaxies are so far away from the Earth that the expansion of the universe causes them to recede from the Earth at a speed faster than light. Another way of saying this is that although the size of the observable universe is increasing, the size of the actual universe is also increasing. The edge of the observable universe cannot keep up with the expansion of the universe, so that many galaxies are eternally beyond our observation. Despite this limitation on observational abilities, the universe itself still has no edge. That's all for this video. I hope you enjoyed it. Let us know your thoughts in the comments section below. If you haven't already, then don't forget to subscribe and press that like button. Also, hit the bell icon, so you could never miss new updates from us. Thank you for watching, and we will meet you in the next one.